Count the initial reactant particles. Count the number of H2O2 molecules represented in the initial reactant container. There are exactly 10 H2O2 molecules initially present. Understand the definition of the equivalence point. The equivalence point is reached when the moles of added titrant, MnO4 to the power negative, are stoichiometrically sufficient to react completely with all of the analyte, H2O2, originally present. Calculate the titrant required for the equivalence point. Using the stoichiometric coefficients from the balanced equation, 2MnO4 to the power negative plus 5H2O2 plus 6H to the power plus gives 2 millinewtons to the power 2 plus 5O2 plus 8H2O. The ratio is 2MnO4 to the power negative 5H2O2. For all 10 H2O2 molecules to react completely at the equivalence point, 10 H2O2 times 2MnO4 to the power negative over 5H2O2 is equal to 4MnO4 to the power negative ions required to determine the species present halfway to the equivalence point. Halfway to the equivalence point means that exactly half of the required titrant, MnO4 to the power negative, has been added. MnO4 to the power negative added. 1 over 2 times 4 is equal to 2 MnO4 to the power negative ions H2O2 consumed. These 2 MnO4 to the power negative ions react completely with 2 MnO4 to the power negative times 5H2O2 over 2 MnO4 to the power negative equals 5H2O2 molecules consumed remaining H2O2. Subtract the consumed molecules from the starting amount. 10 minus 5 is equal to 5H2O2 molecules remaining Mn to the power 2 plus produced, according to the 1-to-1 ratio of MnO4 to the power negative to Mn to the power 2 plus in the balanced equation. Adding 2 MnO4 to the power negative ions produces 2 MnO4 to the power negative times 2 millinewtons to the power 2 plus over 2 MnO4 to the power negative equals math 2 Mn to the power 2 plus ions formed remaining MnO4 to the power negative. Because we are prior to the equivalence point, the analyte, H2O2, is in excess. This means all added titrant, MnO4 to the power negative, reacts completely and none is left over. 0 MnO4 to the power negative ions. Select the correct particle view. The correct container must depict 5 H2O2 molecules, 2 millinewtons to the power 2 plus ions, and 0 MnO4 to the power negative ions. This matches option C. The correct answer is option C. Visual. Particle view container showing 2 millinewtons to the power 2 plus ions and 5 H2O2 molecules.